Jesus. Light of the world, you step down into darkness. Open my eyes and let me see beauty that made this heart adore you. Hope of a life spent with you. Oh yeah. Here I am to worship. Here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me. King of all days, oh so highly exalted, glorious in heaven above. Humbly you came to the earth you created. Hope for love's sake became poor. So here I am to worship. Here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me. Yeah. I'll never know how much it costs, Jesus. My sin upon that. Oh, thank you for your sacrifice. I'll never know how much it costs to see my sin upon that cross. So here I am to worship. Here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me. So here I am to worship. Here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether
All right. Good evening. Good night, everyone. I'm thrilled. I see we have several that are on with us live. I want to take a moment to just say thank you. Welcome. Thank you for joining us. Please take this opportunity to share this video out. We want as many people to get a copy of tonight's presentation. We want as many people joining in, sharing in the comments. Good evening to you all. I want everyone to know that as we're sharing here tonight, yes, good evening, Sister Elizabeth. I see you. Good evening. Yes, please take a moment to, as you're logging on, to share. We want as many people signing on and sharing in the comments. Let us know your thoughts, your questions as we're going. Good evening. Elder Escorts, good evening to you. Yes. So everyone, I want to introduce you to a new colleague and friend of mine, Dr. Kerby. A matter of fact, I want to take a moment and I want to share with you a little bit of information about tonight's presenter, Dr. Kerby C. Oberg. He is a professor of pathology and human anatomy from the Division of Anatomy of the School of Medicine at the prestigious Loma Linda University in Loma Linda, California. So please join me in welcoming our presenter for tonight, Dr. Kerby. He will be sharing and breaking down tonight the science of our sexuality. Good evening, Dr. Kerby. Please say hi to everyone.
Greetings. Hello to everybody. Thank you for this opportunity to be with you tonight.
Awesome. Now tonight, it is going to be along the medical side. I know that previous presenters, we shared and we talked a lot actually about the theology. We dove into the biblical side of things, the theological, right? But tonight we're going to get into the medical. Now, I want to make that abundantly clear. I am not a medical doctor. Always wanted to be, but no, I'm not a medical doctor. That's why I brought an expert, someone who actually, this is their field of expertise, to come in to share with us. I know that several of you have sent in some questions, and we're going to do our best tonight to dive into those questions, all right? But I want us to understand that science and religion are not at odds. They're actually working together in a beautiful, harmonious way. And I wanted to prove that and show that. So each and every one of us, we can see like, oh, wow, God is doing amazing things, all right? So I want us to understand the beauty of our sexuality from all sides. God designed it beautifully, and science is here to dive into it, investigate it even more, right? So I'm just giving everyone a chance to kind of understand the goal for tonight. All right. So this time I'm going to turn it over to Dr. Oberg, and he's going to be presenting here tonight. And I do have your slides, Doc. So
It looks like I can present from here. It said there's a present at the bottom. Is that something I can try to do?
Oh, I have it here.
You got it there.
Yes.
Very good. So if I just ask you to go to the next slide, that you can do that then, right?
Awesome. Yes.
So I am thrilled to be with you. This is something that I get a chance to study as well as I do clinically. I'm a pediatric pathologist. That's my clinical hat. And I study congenital anomalies and birth defects. And I'm also a PhD in developmental biology and get the chance to actually study how are we put together? What are the genes that give me a nose that looks like it does, and the hands have 5 fingers, etc. And so from my viewpoint, this is just an incredible gift to be able to see God's handiwork from the point of a single cell as it morphs into a beautiful little embryo. If you go to the next slide, I think I have, this can just show you basically we start out as a sperm and an egg, and through a huge series of events, cells turn on different genes that precisely divide the cells in a certain way so that we then morph into this beautiful little embryo that's in the middle, and then finally into a baby that it looks much like mom and dad, and then goes on up to be hopefully not just a joy to the parents, but also to our families, and to make a difference in the world as God would have them to do. So for me, this is just an incredible journey to be able to study this process. This process is complicated. I'll say that up front, it may sound easy for an egg and a sperm to come together and then boom, magic happens and a baby is born. We are trying to understand how God built in us this incredible gift of how to morph into 5 fingers and to have a heart that beats early in development, etc. If we go to the next slide, there are several things in the last 50 years that have really impacted how we understand developmental biology. There's a number of animal models that I study. I study chicks, mice. I don't do the fish and flies and worms, but there's others that do. I also work within human genetics. And so there is a online depository of all of our genetic information for disorders or known pathologic variations that we have cataloged in over 26,000 different types of genetic variations that have some type of outcome that gives us clues about how the process of development occurs. And there's been 50 years of genetic information and of embryo information that's led us to this point. Question, Richard, I thought I heard you saying.
Oh, no. I'm just listening. This is a beautiful class for me right now.
There you go. So this is the part where the journey is going to start. And if you can go to the next slide, please. If we take a look at the process at the top of the screen, you can see basically there are 4 things that I study in when I talk to medical students about how do you build the reproductive system in a human. And that starts out with actually setting up what the gonads are going to be. We all start off with exactly the same equipment internally and externally. And it is with hormones and with unique gene regulation that we turn into either male or female largely. And I'm going to say it that way because there are about 25 different genes associated with this process of making a gonad. And they can be at array. And something can go wrong with one of those 25. One of those genes is on the X or the Y chromosome. The rest of them are in other genes, which we call autosomes, that aren't associated with the chromosomal sex determination, which to me is just fascinating. And the 4 different systems that we're going to talk about, this is supposed to be an overview, and I'm getting carried away and just chatting too much. But gonads, we'll talk about what we call the genital duct system, which is really the plumbing inside that's going to take from the gonad, which is creating our sex cells, either a sperm or an egg, and then bringing that to either the uterus or bringing that to be deposited within the uterus from the male system. So we talk about the internal genital ducts, and then we'll talk about the external genitalia and how it gets morphed into position. Then finally, the 4th thing in this is really brain imprinting, which also occurs by the level of hormones that we have. So these 4 systems are relatively complicated. And if we go to the next slide, I think we start out with the very first part. Most of us know that a sperm and an egg come together, and when they do, an egg can either have, it only has an X chromosome that's contributing, whereas the sperm can bring in an X or a Y chromosome. And so once you have an XX, that's typically female. And if we have an XY, which I think is down just below that, I'm not sure if it's being shown on the screen or not, but an XY gives you a male typically. And I say typically because that's the vast majority. We toggle between that, but there is this boundary when some of the genetic material is variant, is different. And then we have what we call ambiguity in between. The next slide, I think we can go to. So this is a complicated slide, but I just want to show this is an embryo. You all looked like this a few years ago. And I don't know that I can actually draw on this one. And so I was going to try to take you through some of this, but let's see if I can. I don't know that I can, Richard. So from this, if you take a look at the illustration on the top, that is a little embryo. You can see there's a heart toward where it says reproductive development towards that end of it. And it has kind of a bent back. And then it has this big yellow section in the middle. That's its abdomen. That has its tummy that's going to be incorporated into it. And there is a population of cells that are going to become our sex cells that are located within that yellow, that little flap that's being pulled down halfway towards the side of the left side of the, I should say this is the right side, I'm looking at it, but the right side of the picture. Those cells migrate into the gonad at around somewhere around 3 to 5 weeks, 6 weeks of development. And they move into the gonad, take up residence, and then tell the gonad what they're going to become based on usually the chromosomal arrangement. But the chromosomes, just to stop for a second, the chromosomes only work if everything is readable. So sometimes we have genes that don't get interpreted. So just having a Y chromosome doesn't mean you're going to develop into a male. If that chromosome has missing pieces or has alternative pieces, you may not be read as a male based on just having a Y chromosome.
Oh, wow. Okay.
So with that, then, and this is showing, the other picture here is showing you, it says genital ridge out the side. That's where they migrate into. And if you go to the next slide, I think it takes you to just showing how then, once the yellow is depicting what the gonads look like in all of us initially, and then depending upon the genes that are involved, and as I mentioned, there's over 25 different genes that contribute to determining whether it's going to become male or female. And there are a number of different sex reversal situations, which in medical literature is well known, where you have an X and a Y, but you're female. You develop an ovary, you develop a uterus, you're phenotypically a female, even if you have an X and a Y. Likewise, there are phenotypic males that have 2 X chromosomes.
Okay.
So having the genetic sex or the chromosomal sex doesn't necessarily mean that makes up our phenotype and what we look like and what we feel like. So, and even what our organs would look like internally. So if you can press the next button, these are some of the different disorders, and that's too many, and that I don't mean to be overwhelming.
Wow.
But all of these are known disorders that have sex reversal. Where the genotype up here in this top one, and I'm pointing to it, but you can't see my pointer.
Yeah.
At the top there, it says genotype 46XY, or down below, it's genotype 46XX. And these are sex reversal syndromes. So next slide. Go ahead.
Now, when you say,
jump in.
When you say sex reversal syndrome, what does that mean? Does it mean that it can be changed, or what do you mean by that?
Great question. Great question. So what it really means is that the phenotype is the opposite of what the chromosomal type is. So when it says 46XY, all of those that are listed underneath that one are phenotypically female. They may have ovaries, they may have a uterus, be phenotypically 100% female, but they have an X and a Y chromosome.
Okay.
So the sex is reversed from what we might expect. So it's not typical of what the chromosomal sex would suggest.
Ah, okay. Okay.
Does that make sense?
Yes, yes. All right.
Okay. So go ahead to the next slide. So after we've made gonads, that's kind of the first initiation of the reproductive tract. After those have been established as either an ovary, which is shown in pink down below, and I should not have used those colors. I should use something else rather than pink and blue. That's way too stereotypical, but hey.
That's all right. That's all right.
And the testis is shown in blue. They have very unique morphology. They started out the same, but then they transform into either an ovary or testis. Once we have generated the gonad as either an ovary or testis, they become a small hormone factory. And the hormone factory produces local hormones.
Okay.
So up at the top of this table, you can see local hormones. Those local hormones are affecting the next step, which is the ductal system. And in men, the ductal system will be what we call a vas deferens, seminal vesicles, ejaculatory duct. And in women, that will be a fallopian tube or oviduct and ovary, oviduct and uterus, and then a vaginal canal. So those are the local hormones, which means you can have an ovary on one side of the body and a testis on the other side of the body.
Really?
And you can produce a ductal system for the male on one side and the ductal system for a female on the other. The female would have a hemiuterus and an oviduct on one side, and you'd have a spermatic cord on the other.
Okay.
And that's what we used to call a hermaphrodite. It's now called intersex.
Okay, now let me ask you a question concerning that. And for those watching, feel free, if there are any questions that you have while you're listening, please share in the comments as well. Now, I had a question concern that you mentioned, use the word hermaphrodite. Now, with an individual that has this variation,
right?
Is there one, like you mentioned, they could actually have on one side have a testes,
right,
and the other side have an ovary. Is there one that would be operational and another that would not be? Or is it possible that both organs will be fully operational?
So good question about fully operational, because they are functional. In other words, you have a testis that will produce sperm and you have an ovary that produces oocytes. So
Wow.
from that aspect, but the big picture is, what will the external genitalia really look like? How functional will it be at that point? Because you have a mixture of signals that will be produced for the systemic hormones. So we're talking about the local hormones that'll make the ductal systems.
Yeah.
But the gonads will also be transformed and make, I should say, the local hormones will be transformed into systemic hormones, which will then contribute to how the external genitalia is going to appear, and also how the brain is going to get imprinted.
Okay.
Okay.
So, comment here says, Dr. Oberg, does the urine environment
The uterine environment. I do the baby stuff.
have an
There's
effect
Willie.
on development? Yes, Dr. Willie's in the house. All right.
There you go.
And he's asking, does it have any effect on development?
So the point is that it sets up both ductal systems and both gonads. So this person is what you would call a true intersex individual. They have both sexes.
Mm.
And when you talk about functionality also is something that happens at the external level, where do they have a penis that could actually function? You know, is it significant enough, or has there been too much estrogen, not enough testosterone? Do they really have both external genitalia? Because you will have mixed signals that now go out to the systemic circulation. We typically would talk about this as a virilized ambiguous genitalia, where it's more male-like, but it all depends on the level of the hormones. So there's no stock right answer about how functional this could be.
Wow. Okay.
Okay.
Yes.
So the other point is that if the testosterone has, or I should say, if the let's go back to the slide before that for just a second.
Okay.
Part of what the testis produces is local testosterone, which maintains the male ductal system, and also it produces another hormone that represses the female ductal system. We all start out with both ductal systems. We all start out as babies, or as I should say, embryos, with both a male and a female ductal system, all of us.
Okay.
And then if you have a testis, you allow the male ductal system to persist, and you produce a hormone that knocks out the female ductal system.
Okay. So one becomes more dominant as you continue with the process.
As you continue with development, two hormones are produced from the testis that will impact these ducts. One is an inhibitory protein that blocks the female ductal system, and the other is a supportive hormone that maintains the male ductal system.
All right.
So if, for example, testosterone persists, or excuse me, if testosterone is disrupted, so there are mutations that can occur within the testosterone gene, so you don't produce testosterone, or there can be problems with the receptor that allows us to recognize that testosterone is even in our body. And that androgen receptor, that testosterone receptor, if either of those are defective, you won't produce testosterone. If you don't produce testosterone, that's where that next slide would come in. You don't produce testosterone, and you don't then maintain the male ductal system, but you repress the female ductal system. So you'll have a gonad. And if you go to the next slide, it shows you, if we go forward. Yeah, there. This one basically shows that with basically those local hormones knocked out, you have no ductal system.
Okay.
And so you would have a testis, but without ducts. This actually occurs in what we call androgen insensitivity syndrome, a clinical syndrome where someone has a receptor that doesn't recognize testosterone, but they still produce the hormone that blocks out the female ductal system. So you have a gonad in the abdomen with no ducts to it, and we need to remove that gonad. It's a testis, but they look like they're female because they don't recognize any testosterone at all.
Okay. All right. So we have a few questions coming in here. Yep. So this first question, it says, Ridgemar says, if we believe that God created us all, why would he create these disorders in some individuals? So,
boy, that's a great question.
Yes.
That's a great question. What God has built into our genetic code is an incredible amount of adaptability and a variation. You know, Richard and I talked about this earlier tonight. If you take a look at your screens, if you can see each other, we all look different. We have an incredible amount of variation in us. What is normal? What is typical? And as I joked with him a little bit, for me, normal is being bald. I think all of you should be bald because to me, that is normal. And the rest of you are unfortunately not normal because you aren't bald if you have hair. The reality is that's part of the variation of how God has built us. We have the ability to be quite diverse. And diverse even in situations like this. There's still adaptability and there's still variation that can occur within the ductal system. So this ability, and I think Anna Daniels has said that there's no one person that has both sexes. No one in this history have ever been able to impregnate themselves. I think that would be accurate from a standpoint of being able to impregnate themselves. But there are a number of individuals that have both male and female ductal systems and that have both an ovary and a testis.
Absolutely.
So how they're able to take it to the next level is part that I think is much far more complicated and depends on whether they appear more masculine or they're more feminine. If that helps with that answer to Anna.
Yes, and also, Doc, earlier you actually touched on that. You said that part of the process is that the gonads will produce hormones, but it will produce multiple. It will produce one that would be either pushing towards testosterone for the male, and at the same time, it will push out another hormone that will actually diminish the female. So the body is actually designed in a way to go towards one side or the other, but within that process, there are variations that happen.
Correct.
If I'm understanding correctly.
Correct.
Okay.
And that's exactly the way that I put it, because there's, and this is the challenge for us, that there's subtle variation in all of us. At what point do we call it a disorder or a defect or an abnormality? Mm-hmm. And that's one that changes is, you know, we like to have people that are like us. That seems normal. So if I hang out with a group of bald people, that feels very comfortable.
Sure.
But we actually are enriched by the diversity. When we hang out with people that aren't like us, we actually are enriched by that process. And that's one of the things my wife has preached to me a bit about the fact that when you sit at the table, you share a meal. If you share a meal with people that are different from you, you come away far more enriched than if you just share a table of people that are just like you.
So true.
And I think that's true.
And Doc, as you mentioned that, I think it's very, very important, because as we're talking about these variations and differences that exist, I believe that it's important that for someone, like for instance, because you are bald, that you don't try to go out of your way or feel forced to say, you know what, I need to go get hair. I need to go get fake hair to put on, right? Or where to pay, you know, or to fit in, right? You know, especially.
But we've done that. Many of us have done that, right?
Very, very much so, because, you know, if it actually makes us feel better, because others might look at us different, like, oh, why don't you have hair? What's wrong with you? Or, you know, things like that. They start to judge or ostracize you for being different, right? We're going somewhere there, right? We tend to ostracize those that are different and I believe that it's important, especially for those that realize, I do notice there's something different about me, that you don't feel as though you have to force yourself to conform, or that, you know, or that because that might be the case for others, don't feel as though, okay, I need to force myself into that mold. Or even, like a better way of putting it, for someone that might identify as trans or homosexual or intersex, right? That you don't have to force yourself into a heterosexual normative,
right?
Because that might be their norm, you know, kind of thing. I believe that there's value in that, right?
This is the way that God has made us. You know, we can talk, and I think you and I touch base on this, in that sin is in the world. There's no question. And none of us are reaching what is the ideal. With the ability to have variation in our genome, God's created the ability to have incredible beauty, but also some challenges as well.
Yes.
Within that. And I think part of the challenge is even on us, on how do we accept people that are different than us and still love them to death.
Absolutely.
And I think that's part of what I look at when I look at this just from the science standpoint. It is a bit challenging for me because it doesn't fit what I thought I knew, because there's a lot more variation in this process than I anticipated. And the fact is, as a physician, I see this. So these aren't maybes. These are things that we see.
Absolutely. Absolutely. And that I
If
believe,
we go ahead.
oh, yes. And I said, I was going to say, that is what I believe is the true challenge of being a follower of Jesus Christ. Loving those that are different, right? And being comfortable with those that are different from you. Oh, I see there is a question here that we had. This is coming in from Brother Andrew Wade. It says, is a menstrual cycle a good deciding factor of a person being male or female?
Boy, that's an interesting question. And maybe Andrew would be surprised to know that we have all the same hormones that cycle the menstrual cycle in women and men. We have what's called follicular stimulating factor, which is what was first named for stimulating ovarian follicles. We also have luteinizing factor, which is involved with producing a yellow body when the ovary ovulates and ruptures. It then makes a factory of steroids to produce more and more estrogens and progesterone. Interestingly enough, we have the same hormones. They cycle a bit also. So when you're talking about the menstrual cycle, if you're talking about someone that was a intersex individual, they would likely still have a menstrual cycle. Men have a cycle of sorts as well, but that produces sperm rather than producing oocytes.
Hold on, wait a minute. I don't want to. This is fascinating. But wow, rewind there a little bit. Did you just state that even for us as men, we have a similar cycle? We
have a cycle that we are going through to produce sperm, but we use the same hormones women use to produce ovulation. Is ours a 28-day cycle? It's actually closer to a 66 or so day cycle, 76 cycle, somewhere in that range, a little bit more than 2 months. But it is still using the pituitary hormones. It's still using these same hormones that women use. And when I say women use, it's really humans use, right? We named it based on the fact that we found it first in women. That's the way science works. But it is basically, we have some of those same hormones. We don't have a uterus. Without a uterus, we don't go through a menstrual cycle. We produce wavefronts of sperm in a cyclic fashion that mirrors what happens with the oocytes in a cycle fashion.
Listen, I've had these types of conversations, but I stated jokingly. I just say, you know what, as men, I feel like we go through a similar cycle. We have mood swings too, but to hear medically that, wow.
Yeah.
I'm sorry. Like,
no.
I'm having a wow. This is fascinating, to say the least. Wow.
And the hormonal regulation is also quite different because our levels of testosterone are a tad bit more consistent than the levels of estrogen and progesterone. Those go through cycles because of the uterus. The uterus is the key organ there that basically is building up endometrium, and then it sloughs the endometrium. And during that process, there's a huge buildup of estrogens and then progesterones that makes the hormonal cycle that we talk about in women maybe more pronounced than what we see in men, because testosterone is being produced at a more consistent rate within the testis. We still have the elevation and decrease of FSH and LH, which are these other hormones that are driving the reproductive cycle, but maybe not the same hormonal swings that we talk about or see that occur also in menopause when those are lost and we no longer produce oocytes.
Oh, all right. So let's do a little bit of summary here before you continue. All right. So far we have touched on the fact that at the start of our reproductive process, we're one and the same, right?
We start out with undifferentiated, the same equipment, both male and female. And actually, if you just go to the next slide, I think we talked about the oversight. We can just end with these two. Yes. It doesn't show it. Okay, go back to that last one. We'll end there on the one before that.
This
because
one?
part of the one before that, even what this doesn't show you is the other side, the ovary.
Mhm.
The ovary produces estrogens, and I'll just end with this, and then we can do the summary on that. But the
Yes.
ovary doesn't produce a hormone that maintains the male ductal system. So the male ductal system, by nature, will regress. If you do nothing, it will regress. So
Hmm.
without testosterone locally, it will regress. The other hormone that is an anti-hormone for the female ductal system is not produced in the woman. So the female ductal system will persist and a uterus will be formed and an oviduct will be formed. So it's possible to have one duct, two duct, and no ducts, and I should say there's the possibility of having one of either duct, or no ducts, or both ducts.
Wow.
And if you had a disruption of the hormone that's blocking the female ductal system, but you still had testosterone, you would have a female ductal system and a male ductal system in the same individual.
Wow. This is mind blowing. Now, I'd actually want to make sure that you don't miss some of your information here. This next slide actually shows.
This is what the external genitalia. So now we've gone through the ductal systems.
Mhm.
We're now at the third level, around 8 to 10 weeks. So this is after the embryo. And if you take a look, if you've ever had an ultrasound done on a gestation, at the end of the embryonic period, which is roughly about 8 to 10 weeks, we can't tell what the sex is yet. Even though the embryo is largely formed and you look like you're going to look, you're just really, really small.
Yeah.
Your external genitalia is still what we'd call ambiguous. It basically is what we all start out with. We all start out looking like this. And then if there is dihydrotestosterone, so that's a transformation of testosterone, there's a modification, there's an enzyme that's necessary to do that. If that enzyme is defective, you won't get virilization or masculinization of the external genitalia. But and I think the next slide, some of these slides don't seem to be working quite on target, Richard, but that's okay.
Okay.
If you go back to that last one, let me just make a comment.
Here.
Well, yeah, and this doesn't show it well, and I don't know how I can show this here to you, but basically the male ductal, or the male external genitalia, is when you take and zipper this structure shut. I'm wondering, is it possible? Let me see if I can do something here really quick, sir,
Okay.
if this is okay. Because
Sure.
it looks like and I'm going to see if I can, will this share? If I do this, if I share.
It's possible.
Let's see, maybe I can't. If I do this, you just see all of that, right?
It still only shows what I'm sharing from my end.
It doesn't show this other. It doesn't show from mine. Okay. All right. Well, let me just make the comment then, and I'll stop that. The sharing part. Let's see. Let me just go cancel. And just say that to make the penis and the male external genitalia, the structures that you're seeing here, what's in red, if you can see the red over on the right-hand side there, the red will get zippered shut, and that will make the shaft of the penis, and the very top of that will be the glands or the top of the penis. And the difference between male and female is really that zippering shut. And again, if someone doesn't have adequate levels of this dihydrotestosterone, and that can happen, and there's a group of boys in Haiti that don't have adequate levels of testosterone, so they grow up as girls till they're about 12 or 13, and when they hit puberty, they produce more testosterone, and it actually zippers everything shut, and they become a male.
Wow.
And so you can have a disruption here between how we form our external genitalia. And I will also say that there are hormones that can be produced in the adrenal gland that mimic the androgens. And so if a little girl has a problem with a tumor in the adrenal gland, or an absence of an enzyme that causes overproduction of an androgen, that little girl can also have zippering shuts of the what we call the urethral folds, the red part on the sides, to make the shaft of the penis, and also enlargement of the penis. Even though she's XX and she's still a little girl with ovaries, that can externally, the external genitalia can be what we call virilized or masculinized. Okay.
Wow.
And that's the external genitalia. And I think then the last or the next slide that you went to is a part that we could stop on and talk about the variations. But just to summarize then, if you wanted to do that from your language, and we can work this out together, just to go through what we set up to this point with the gonad and the ducts. Or do you want to do that? Do you want me to do that?
Yes, you'll be, I think you'll be better to do that than me.
So the bottom line is that we all start out with the same gonad. We then, depending upon what our genes tell us to do and the hormones tell us to do, we transform that into either an ovary or a testis. These early reproductive organs are also hormone factories, which then basically take care of their local environment to produce the ductal system associated with this gonad. And then the hormones are transformed into other additional active hormones for the systemic circulation. Particularly testosterone is transformed into dihydrotestosterone and then made into a systemic hormone that goes to the external genitalia to transform the external genitalia into either a male or female. And if the elevation is high, it goes into a male. And at that point, we've got the ductal and the external genitalia. Now we get into what I think is the most difficult, which is really going on with what happens within the brain.
All right.
And what I'm showing you is just, these are our medical reproductive variations that we see. So at the top there is showing you something that is a histologic slide of an ovotestis, where someone has both an ovary and a testis, where a portion of the gonad turned into an ovary, a portion of it turned into a testis. This is a pathologic specimen, something that I have actually seen in practice. You can also have the ductal system, as I said, and that's what you're showing you here, 4 different pictures of ductal systems, one being male, one being female, one being both, and one being neither, where you have no ductal systems. So 4 variations that can occur at our ductal level. And then the external genitalia also toggles between male or virilized and feminized. And what you're looking at, the picture down below there, is an ambiguous genitalia, and I apologize for the frankness of that, but that is an ambiguous external genitalia that's neither really apparent as a male or a female.
Wow.
And so this is where at that boundary, and that's what I'll summarize, and then we can just chat about it. But that boundary is where we have ambiguity. It's when there are variations in each one of these processes that doesn't toggle between male and female, is we have individuals, and I would still say that are a gift from God, but are people that are in between and in this ambiguity.
All right. So I want to pause here for a moment to kind of absorb all this, because this is a lot, but also to give, for those that are watching, if you have any questions, feel free, you can share there in the comments and we'll definitely address them. So I wanted to take a moment, especially as we were looking at this. I'm still amazed by even the top slide, top right. It shows the ovary and the testes together. And you're stating this is actually from an actual person. This is not just an illustration. This is
that's real.
Wow. Correct. That's mind blowing. Now let me ask this question, Doc. Are doctors starting to realize, are there key factors that might trigger these variations or cause these variations? And if so, are there methods to, I guess, change or adjust these changes?
So the first step is identifying what's the underlying cause, right? And I think we're getting better at that with our genetics, and we can identify when, the fact that you and I look different is due to about somewhere between 8 and 12 million what we'd call point mutations or point variations in our genome.
Wow.
99.9% of our genome is identical, yet we don't look like clones.
Yeah.
And the part that makes us different is this, maybe 8 to 10 million variations in whether it's a G, an A, a T, or a C. That's our basic building blocks for DNA. And at various points throughout our genome, we have a subtle change and a subtle difference. And those can change how a gene is turned on or turned off, how long it's turned on or how long it's turned on, how much it produces.
Mm.
And so it's regulating the genes that we all have. We all share the same collagen gene that makes collagen for our nose, that makes it bendable. But whether I have a big, huge nose or a tiny little petite nose is about how long that collagen is left on and how long the programming for making a nose is regulated.
Mm.
That's the variation in us. When that variation comes into play within our reproductive system, that also makes changes. And if we can identify what those variations are, we can better understand whether there is an ability to intervene or not. For example, the little girl that's associated with external genitalia that looks like this has a high level of androgens being produced in her adrenal gland. We can identify that early on after she's born and quickly try to repress the excess androgens that are being produced and get her adrenal gland to produce more normal levels by giving her supplementation. So there are ways that we can treat that so that she can get back into what her initial biology was built for.
Okay.
If that helps to answer that.
Yes, definitely. And I see a follow-up question here. It says, can an imbalance in parents' hormones, test or estro, affect the sex and development of a child? Very good question there, Andrew.
So can an imbalance in the parents? Yes. So for example, many of you have probably heard of a syndrome called polycystic ovary disease. Polycystic ovary disease actually produces androgens.
Okay.
So if you produce androgens, that can impact, if you're a little girl, that can impact what your external genitalia will look like. If you're a little boy, it's just more androgens on board and it probably won't make much of an impact. The part that we don't fully understand yet is, what do those androgens do? And we haven't talked about it yet. What does those androgens do in terms of imprinting in the brain?
Yes.
And the brain has about 2,200 genes that we have been able to map so far that are associated with sex-related silencing or variation. And this is complicated, so let me just take a second to make more of a comment about this. Men and women have all the same genes. However, when we build our babies, men give a set of genes that have been imprinted as male. And women give a set that have been imprinted as female. Together, you put those together and you make a baby that has both a set of genes from a male and a set of genes from a female. Each one of those chromosomal sets is slightly different in how they're regulated. Some genes can be totally silenced, which means there's subtle modifications, not to the actual DNA, but to what we call epigenetics. There's ability to turn a gene off or turn it on by making it what we call accessible or not accessible. If I take and wrap the gene up and put it in some aluminum foil so you can't see it, you can't make protein from it. And in essence, when we methylate those genes, we are making them so they're not accessible to be read. And because we don't need two copies of some genes, there appears to be an order, and we don't understand this yet, but some genes are silenced by mom, some genes are silenced by dad. The best example of this is a tumor that's produced in women when they have what's called a trophoblastic or a placental tumor. The placental tumors are all male DNA. Somehow the female DNA has left. We don't know how, but it's all male DNA, and the male DNA has been imprinted to make placenta, but has no clue how to make baby. Wow. So no baby forms in this gestation, but it makes too much placenta, and this placenta can actually then make a tumor that migrates in and becomes malignant and goes to the lungs. So that's imprinting to make a placenta. When we talk about the brain, these 2,200 and some odd genes that are involved with sex variation, those are imprinted differently in males and females. We have no clue yet what they all do. We know that they're involved in, and they're imprinted by either high levels of testosterone or high levels of estrogen. But we don't know how they change how we think, change how we feel, change whether we're sexually attracted to a male or sexually attracted to a female. But those genes are imprinted. after we get done with the external genitalia, those external hormones that we talked about that are systemic also impact the brain between 16 weeks and 20 weeks of gestation. There's high levels of estrogen and high levels of testosterone. And if we have high levels, and this is a very long answer, Andrew, and I'm sorry, but if we have high levels of androgens present when they weren't supposed to be present, we actually change the imprinting in the brain. That's been demonstrated in a vertebrate model. It's not been demonstrated quite the same in humans yet, but it's been demonstrated in a rat and a mouse model where you can imprint the brain differently based on that. And this is showing an example that was done in fruit flies. And so fruit flies aren't at all like us. They're actually fairly simplistic to work with. The gene that's associated with behavior, and I love this because they have one gene associated with behavior. We probably have 22,000 that are associated with behavior or whatever, the subtleties of humankind.
Mm-hmm.
But with this one behavioral gene, there's a male variant and there's a female variant of the same gene. And this is a complicated picture, but part of what it's trying to show you. And if I can go ahead and make a comment here, Richard, if you want to see this more fully, take a look at, there's a video that I sent to Pastor McNeil that he can make available to you folks that goes through this, and you can go through it. And I'm happy to also take email questions after this next 2, 3 weeks, 4 weeks, whatever you want. But in this process, it's showing you a diagram of a gene. So if you take a look at the white and then the dark green and the light green in the diagram off to the right, and the words are on top of them, so you can't see. It's supposed to be androgen and estrogen to show you two different variations there. Okay. But if you take a look at that image, we have what's called exons that are producing protein and introns that are gaps between what's going to make protein. And this is looking at the gene component. And if you take a look at what's called the FRUF, the female version of this protein that's going to be made, they're both from the same gene, but depending on whether there's estrogens present or whether there's androgens present, they will make a different protein product.
Wow.
And this protein product affects whether you behave as a male or behave as a female. And they can take the male, it's called the fruitless gene, and they called it the fruitless gene because if there was this mutation in the males, they didn't reproduce. They acted more like a female, and the fruitless mutation gave the FRUF variant, which is the female variant. If you take this female protein and you inject it into the male fruit flies, there's a video that goes with this that they can see on the actual video that I sent you. But that video shows fruit flies that are males with other, I should say females that have the male variant. I should say they have the male variant, and the females have no anatomy of a male, but they still chase. They have the behavior of a male. They chase, they try to corral the females. So that's a simplistic version of at least 2,200 genes in humans that we've identified that are differentially expressed and repressed.
All right. Wow. And that's fascinating there.
And I'm sorry, Elizabeth. I see that this is over, and I'm sorry. I apologize.
Well, no, but that's actually that's actually the point. And I love what you stated earlier in that we need to be a lot more humble with how we address this issue of sexuality, because there's so much that we're still learning. Correct. Right? I like the fact that you were open in sharing and saying, hey, listen, here with the fruit fly, I believe it's one variant that is being talked about here. But for human beings, there's how many thousands that you mentioned?
There's 2,200 genes that in one study that we looked at in the thalamus. So that's one portion of the brain. And there was 2,200 genes that were differentially imprinted, either as male or female, based on the estrogen and testosterone levels.
Right. So
if you go to the next slide, this is one diagram that kind of shows that, I think. And this is a representation. The color blue and pink or red is just telling you what's active and what's not. And if you take a look at the females, it's showing you, this is just 70 genes, but it's looking at 70 different genes that are active in females that are not as active in males. And when they knock out this one enzyme that's involved with methylation, which is silencing the gene, wrapping it up so you can't have access to it. You convert a female into more of a male pattern of methylation.
All right. So especially that process that you just mentioned there, this actually, as I'm looking at one of the questions that was brought, that was sent in, is there a gay gene? Or are there genes that can be addressed? Has any of that been found?
Yeah, I think what there isn't, like in the fruit fly, a single gene that says behavior.
Okay.
We know this, right? We know that we're far more complicated. People have a huge variety of what they find interesting, and what they find attractive.
Yes.
And because of that, it is likely not a single gene, but there is what we'd say are certain types of behaviors that we often see more likely in little boys, maybe, or in little girls. And this is where the transgender issue comes up. Whereas if a little boy is behaving much more and prefers to play in certain ways with, things that are more feminine typically, that's not one behavior, but that may be multiple things that tend to seem like that's a little bit more like a feminine behavior versus a masculine behavior. And it is common for these imprints to occur between 16 and 20 weeks. And then again, when we hit puberty, we all know that puberty is just a horrible time for teenagers in general, right? Yes. And during that time, you have elevated hormones, both in males and females. And there's all kinds of things that are changing as far as how we perceive the world, how do we perceive our own bodies, how we perceive others. And so that's a secondary time when there's imprinting that's occurring within the brain. And part of what's really fascinating is that the brain is accessible to be imprinted throughout life. So a question you'd asked me earlier, could you change your maybe brain imprinting to be more in line with your biology, for example? Say I am a biologic male with a male body type.
Right.
But I feel like I'm attracted to males rather than females, or I feel like there's other things going on that make me feel more more feminine, maybe in a way, as far as my attractions. Could we change that with hormones? And the reality is it's possible you could. When we have someone that's transgendered and they go on hormone therapy, the hormone therapy is to help them often feel comfortable with who they perceive themselves to be. And with one of the questions I've been asked, well, why wouldn't they want to be more like their biologic body rather than like what their brain thinks? And that's an interesting question to all of us. Would I prefer to lose an arm, or would I prefer to lose my mind?
Mercy.
And the point is, our minds are part of who we identify with the most, not our bodies as much.
Absolutely.
So when you're talking about a transgender individual, to have them change their mind and morph it into something that they don't feel comfortable with would be hard for most of us to do.
Absolutely. Absolutely. And that's a very, very good point, because the mind tells the body what to do, right? So I definitely understand that desire to go with what's going on in the mind of the individual.
And to try to support that. And I think that's what most transgender individuals try to do.
Absolutely. Absolutely. All right. Now, we want to take a moment here to kind of pause so that everyone kind of...
Maybe because I know I've said way too much too quickly. And if there are specific questions I can try to answer, I think there's only one more slide after this anyway.
All right.
That's just the big summary of the fact that, and maybe we'll just go through this real quick, then open it up for all kinds of questions if we like.
Yes.
But reproductive development is a sequential process, really, of 4 systems: the gonad. We then talk about the ductal systems. We then talk about external genitalia. And we need to talk also about brain imprinting, because that's also an important part of identifying who we like, who we feel like we are as well. And then structural reproductive variation. This is something that from a medical standpoint is just a reality that any physician is aware of, that we do have these variations in discordance in biologic, having an ovotestis or having someone that has no ductal system. We see these.
Yes.
And so that's that part to us. There's no question about whether that's reality or not. The brain imprinting is the one that's more challenging for us. It's in the last probably 10 years. In 2015 is when I first recognized some data on this from the imprinting standpoint between male and female differences. And that's one we don't see a phenotype with per se, but if we can start imaging the brain and seeing the male and female imprinting, the silencing, or whatever's happening with the genetic basis, that might give us some more insight into the quotes phenotype, like an ambiguous genitalia. And it's likely, and I think just hang on, because we're going to learn more about this in the next 10, 15 years. We continue to explore and understand more about it. But I think the bottom line in this, from my viewpoint, is simply, we're all children of God.
Yes.
And from a medical standpoint, I'm trying to figure out how to make people whole. And that's a challenge when we're imperfect individuals and we have all this variation. What's my goal for taking someone that is, maybe has an ovotestis? What will really make them whole? Getting rid of the ovotestis will take away sex, or away their identity, or what would that do to them? How will that change them as a child of God? And that probably is the most important question I can ask myself. And I don't have answers for that, but that's the constant battle with every individual that I would come in contact with.
Yes, and I like the fact that you share that. For one, we're still learning, right? Two,
Correct.
that the changing of others or addressing others, and whatever changes that might be needed, I believe that there's definitely a big need for compassion, a big need for empathy, and a big need for, let me not push my normative on others, right? But seeking to understand what is happening with them, especially from the medical side of it. There's still a lot to be learned, a lot.
Absolutely.
Right? And especially for us as individuals, as we're seeing that there's a variation, a variety that exists. And as believers, how can we live with others? How can we live with those that are different and live with the varieties that exist? It says, oh, here's a question. It says,
Yep.
Can someone be asexual? Asexual.
So I'm going to throw this back at you in some ways. So don't take this wrong, Joan, but there's a lot of variation in all of us, right? We talk about alpha males to feminine males. We talk about alpha females to feminine females. Can someone just be not interested in sex? I think that the answer to that is yes. So when you say asexual, if you're meaning how I feel about it or how I'm interested in it, I think that that's a yes. If you're talking about biology, can someone not have a sex? You can talk about ambiguity. And so they could be somewhere in between, where the body has left them as ambiguous. You can have ovotestis and you don't have a clear push towards male or female. I think that's uncommon. However, we see in the animal kingdom about 5 to 10% of the time, you will get some variation in the reproductive process, which that's a lot larger than we would have anticipated 30 years ago or 40 years ago. But there's some variation in that process. But asexual is probably right on that midline when you're neither. You have that ovotestis and you really aren't differentiating yourself into either male or female. And I think it can be a brain thing, but I'm not sure how the biology would function out on that. I'm not sure if that helps you, Joan, but that would be my best answer on that. So
the distinction of asexual, so if I'm understanding you correctly, because the question is, can someone be asexual? So if I'm understanding correctly, what you're saying is that biologically or physically, you may have where the organs might not be fully operational and so forth, but there's also a mental side to it as well. It can exist in both. Is that what you're saying?
Well, I'm saying we often limit this to just our external appearance, but to be really, we're sexual creatures, which means our mind's involved as well. Right. Can someone be just not interested in sex? And I think the answer to that is yes. Can the person be asexual in that they're, we talked about, people that are, that look neither male or female, I think would be the question. Can you look, and there are people we know that maybe are on that boundary line a little bit, the jaw might be a certain way. The body habitus might not be quite female, might not be quite male. It may be intermediate. And I would say that is a yes. The body habitus can be intermediate. But we're a sexual being. That's a complete thing. So I think the mind has to be involved with that as well. But I don't feel like I've done a very good job of that, John. I'm sorry. I feel like it's a great question and a hard one to really answer with clarity.
Yes, but I can see in a comment she gives you a thumbs up. But Doc, I want to thank you for sharing. You shared a lot with us tonight, and I see we're right around an hour.
Okay.
So I want to stop here for tonight. But I want to say that this has been a learning experience for me. I want to thank you for sharing, because there's still so much that we need to learn. There's still so much that is our knowledge is growing, which I think is a beautiful thing. The fact that we don't know everything is not a bad thing. I think it is a meaningful process. And it's also a call for each of us as believers to truly depend on Christ. The call of the Christian walk is not towards it's not saying, oh, everyone has to be this way. The call is really to live in holiness, to live righteously, right? And the only way we can do that is to truly model Christ. And Jesus Christ, he identified our varieties. He didn't condemn us for our varieties or variations. He accepted us and he loved us. So each of us as believers, we're called to be loving just as Christ has loved others. So, Dr. Oberg, I just want to say thank you for sharing with us. I truly appreciate your time. Dr. Davis is also thanking you. Yes. And
so, Willie, I have to go all the way across to Georgia to say hi to you, huh?
Oh man, but it's good. It's good that we can connect like this. And I just want to praise God for the beauty of technology, because without technology, we wouldn't have this opportunity, at least not as readily. So I want to thank all those who took the time to tune in tonight as we welcome in the Sabbath together, as we learn about God's creation and the variety that continues to exist in God's creation, even with us as human beings. All right. So I just want to thank you all for joining. Doc, before you go, I would love to have a word of prayer with you. Amen. Let us pray together. Heavenly Father, Lord, thank you. You continue to teach us. We continue to learn more and more about the intricacies, the beauty, and also the dynamic, the challenges that exist within our creation. You've created us in your image, and you are a dynamic God. Lord, I pray that you continue to bless us. As we're now within your Sabbath hours, help us to enjoy this time with you. I pray a special blessing on Dr. Oberg, his ministry, as he teaches, as he lectures, and as he shares the knowledge that you have blessed him with, as he shares it with others. Oh, Father, I pray that we will learn to be more loving, we'll learn to be more compassionate, and especially we will be humble. We'll humble ourselves before you, understanding that we do not know it all, but you do. So we surrender to you. Lord, I pray that you bless Dr. Oberg, bless his family. Bless him in every single regard. Be with him health-wise, protect him. Be with him mentally, emotionally, and spiritually. Draw him closer to you, we pray. In Jesus' name, amen.
Amen. Thank you much.
Well, good night, everyone, and happy Sabbath.